this is a model of cis-dinitrogen difluoride. So we look this molecule, all atoms on the same plane. This molecule is planar molecule. We look from the front view, from the side view, and then we look from the top view. Yes, all atoms on the same plane. Alright, so now we are going to find out the symmetry elements operation for this molecule. So the first symmetry element operation is we want to find out the rotation axis. So I look this molecule from the top view. I can see that these two fluorine atoms, if we rotate 180 degree, we will get the same configuration before and after. So I want to find out where is the rotation axis. It means that C2 exists. So I find that this is the C2 axis passing through the nitrogen bond here. So it means that this fluorine and this fluorine rotate 180 degree, we will get the same configuration. Or if we look this position, so it means that the axis here passing through the nitrogen bond, so we rotate 180 degree like this. Alright, so now how to label on the two-dimensional molecule. This is the C2 axis on the same axis. Also C1 360 degree rotation. Okay, the next symmetry element operation is we want to find out the reflection plane. So this is the C2 axis. So C2 axis is the main axis here. So because this is planar molecule, it means that we can have a plane that can cut through all atoms. It means that cut fluorine, nitrogen, fluorine and fluorine here. So this plane actually is parallel with the main axis, which is C2 axis. So this is labeled as vertical plane. And I noticed that this molecule also has another plane which is cutting through the nitrogen bond. So like this. Okay, you can see we cut through the bonding, we will get the same configuration. So this plane also parallel with the main axis, C2 axis. So this is also vertical plane. Right, however, as what we can see here, these two vertical planes different each other. One plane cutting through all atoms and another plane cut through the nitrogen bond. So we can differentiate, put the prime here. However, we can also conclude that this molecule has 2 sigma V. So now we are going to list all the symmetry elements operation for this molecule. So identity, yes, C1, C2, and sigma V prime. Or you can also write 2 vertical plane. Okay, So finally, we want to find out the point group for this molecule. So we look at the list of the symmetry elements operation for this molecule. Has C2 and also vertical plane. So it means that our option, we have two options. So the first, it can be CNH or it can be CNV. So because this molecule has no horizontal plane, so it means that the best answer is vertical here. So the point group for this molecule is C to V. This is the answer for this molecule.